Warm-up is on the board. How do I do it?
Divide by 2x. Or divide by 2.
Yeah, you're going to take out a 2, so you get 2x to the 4th minus 16. Then what? Yeah, it's a difference of two squares, right? So x squared minus 4, x squared plus 4. Are we done? No, why not? Yeah, this is a difference of squares again. So we have x minus 2, x plus 2. Can I do anything with this? No. It just stays x squared plus 4. Good. We are going to be doing a lot more factoring like this chapter. So be aware that is coming. Today we are starting 6-1, as you can see on your green sheets. If you didn't pick up a green homework sheet, they're right up here. We're going to do 6-1 today and then 6-2 over 2 days. During that time, we'll also go over your tests and get your homework checks back. So that's the rest of this week. Any questions? All right, today we're doing section 6-1. It's all about using properties of exponents. So our goals are to use the properties of exponents to evaluate and simplify expressions involving powers. Today's lesson is pretty short. You'll probably have some time to work on your homework. We will have one more homework check, one more quiz, and one more test before the end of the semester. So make sure you're keeping up on things. It's going to go pretty quick. We only have about 3 solid weeks of class left after Thanksgiving break. And one of those weeks is going to be finals. So we really have to get working quickly. All right, so we're going to start by reviewing the properties of exponents. So the first one we're going to look at is the product of powers property. So that says if you have two expressions being multiplied together that have the same base, you can just add the exponents. So an example of that would be 3 squared times 3 to the 7th. They both have 3 as their base. So you can just add the exponents and make it 3 to the 9th. Now, you should all have calculators in this class, so you could actually type in 3 to the 9th in your calculator and get a numerical value. Sometimes you can't, though. If it would be like a to the 2nd times a to the 7th, then you would just tell me a to the 9th. But if it's a number like this, I would like you to put it in your calculator and give it a value. This chart does not, though, because I know you guys know how to evaluate exponents. We're just talking about the rules here. Questions on that one? The next rule is the power of a power. So now we have one base with an exponent to an exponent. When that is the case, you can multiply the exponents. Here's an example. 5 to the 2nd to the 4th is like 5 to the 8th. Again, because we do the 2 times the 4. A lot of people get these two confused. Remember, if they each have their own base, like up here, that's when you add the exponents. If it's one base, exponent, exponent, that's when you multiply. Questions? All right, the next one is the power of a product property. So they're taking a product to a power. So a times b all to the m is like a to the m times b to the m. Here's one with some numbers. 2 times 3 to the 6th is like 2 to the 6th times 3 to the 6th. What are your questions on the 3 properties that are on the board? All right, next we're going to talk about the quotient of powers property. Quotient means division, so now you're dividing two expressions with the same base. So a to the m divided by a to the n Here we just subtract the exponents. So it's a to the m minus n. Looking at it with actual numbers, 3 to the 7th divided by 3 to the 5th is like 3 to the 7 minus 5, 3 to the 2nd, which of course is 9, but like I said earlier, we're not really evaluating them here, we're just looking at how the exponents are affected by these rules. Yes?
So, can there be different numbers, like, for A on top and bottom?
Nope. A has to be exactly the same. If this was like 3 to the 2nd and 4 to the 2nd, there's nothing you could do with that. Nope, they have to be exactly the same. Alright, the next one. Power of a quotient. So now you have the quotient and you're taking it to a power. Here's A divided by B all to the m. It's sort of like distributing, not really, but what we're saying here is that you can take each one of those, the numerator and the denominator, to the m power. Looking at it with actual numbers, 4 over 5 all to the third is like 4 to the third over 5 to the third. Here's just some additional things you need to know about exponents. Anything to the 0 power equals the number 1. So 256 to the 0 power still equals the number 1. Anything to the 0 power is 1. Another thing about exponents you need to remember, anytime you have a negative exponent, it's like taking the reciprocal. So if you had a to the negative n, you can just move it to the bottom of a fraction and it makes the exponent positive. So a to the negative n is the same thing as 1 over a to the positive n. All right, here are some examples. So the directions say to evaluate the expression. So number 1, I have 2 to the third to the second. What can I do here? Yes? Yeah, you multiply the exponents here. An exponent to an exponent means multiply. So this is like 2 to the 3 times 2, which is 2 to the 6th. 2 to the 6th, if you type it in your calculator, you get 64. Now, don't forget the basic rules of order of operations here. Because what is 2 to the third?
16.
2 to the third? 8. What's 8 squared? 64. So even if you forgot your exponents rules, you could use the order of operations here, you'd still end up with 64. But like I said earlier, sometimes this will be x to the third to the second, so you can't really rely on order of operations. But don't forget the basics as you're going through these. Here's number 2. 8 to the third times 8. If I wanted to put an exponent with that second 8, what would it be? To the first. Good. So what do I do with the 3 and the 1? Add them. They each have their own base, so we add them. That's 8 to the fourth. When you type 8 to the fourth into your calculator, you get 4,096. Questions? All right, here's number 3. We have 3 squared to the 4th. What can I do? Multiply the exponents. Good. That's the same thing as 3 to the 8th. 3 to the 8th is 6,561. All right, here's number 4. So I have 2/3 to the 3rd. What is that the same as? Very good. You can take the numerator to the 3rd and the denominator to the 3rd. 2 to the 3rd is 8. 3 to the 3rd is 27. Number 5 is 1/5 to the -2nd. This one's a little different. Any ideas? Can anyone explain how I went from one step to the other? This is kind of like 2 steps at once. I heard someone whisper it. The R word, reciprocal. Anytime you have a negative exponent, it's like taking the reciprocal. So you could flip this and then take each of them to the 2nd power. Or you could really do it the other way. You could take them each to the -2nd power right now. 1 to the -2nd moves the 1 to the bottom and makes it to the +2nd. 5 to the -2nd moves it to the top, makes it 5 to the +2nd, which is just 25. Last one on this slide. So they have the same base. So what can I do with the exponents? Subtract them. Good. This is like 3 to the 1st, which is just 3. What are your questions on exponents so far? All right. They're going to get a little more challenging on this slide, but this is actually our last slide of examples today. There's 10 examples. So number 7, in parentheses we have 2x to the 2nd all to the 5th. What can I do with that? Multiply the exponents. Good. Now be careful with this because 2 technically has an exponent. What is it? 1. So for the 2, you need to multiply 1 and 5. So that's 2 to the 5th. For x, you need to multiply the 2 and the 5. So that gives us 32, because it's 2 times 2 times 2 times 2 times 2. It's 32, and then we get x to the 10th. Questions? Here's number 8. There's a couple different ways to think about number 8. Any ideas? Yeah, we can subtract the exponents. What's -2 minus 3? -5. Good. Which would put that where? Y to the -5 goes to the bottom, right? That's one way to think about it. The other way to think about it is to just think of the way it's done on the board. Y to the -2nd moves the y to the bottom and makes it a +2nd. Now look, the bases are the same, so you can add the exponents. Either way, you should get on the bottom y to the 5th, on the top just a 1. Questions on that one? Kind of tricky? All right, here's number 9. They have the same base, so what can I do? Add the exponents. What's 3 plus -5? Negative 2. So where would the 3 to the negative 2 go? It has a negative exponent, so it would go to the bottom. Good. And then 3 squared on the bottom of a fraction gives you a 9 on the bottom of your fraction, a 1 on the top. What are your questions on that one? Here's number 10. Again, a couple different ways you could think about number 10. Order doesn't really matter though, so you could either take the negative exponent, move it all to the bottom, and then take each term to the third, or you could take it to the negative third and then move it to the bottom. Doesn't really matter. On the board, they are taking x squared to the negative third, which gives you x to the negative 6th. Y to the 4th to the negative third gives you y to the negative 12th. And then you move them both to the bottom and you make the exponent positive. What are your questions on the 4 problems on the board? Bonus, number 11. Sorry, I thought there were only 10. Snuck an extra one in there. How do I do this? Subtract the exponents. Good. They have to have the same base. So you would think of the x's together. X to the 4th over x to the 1st gives you x to the 3rd. Good. Y to the 10th over y to the 3rd gives you y to the 7th. Good. Here's your homework. It's also in the green sheet. Let me know if you guys have questions. You have a pretty large chunk of time left. You could probably get this done in class. Remember, though, you will have a homework check before the end of the semester. So keep up with this homework. Some of the assignments are pretty lengthy, as you can see looking through your assignment sheet. So do not let them get away from you. Any questions?